JP, you got to use your own.
Sorry?
You have to use your PC.
I have to use my PC?
Yeah,
okay.
If needed, maybe you send it to me and we can use mine, or
It's okay.
let's try.
I will use mine. I try to make it ready then.
No problem. We got time. We're way ahead of schedule. We got a 5-minute grace period, so we're still 5 or 6 minutes.
Good. Okay. One, two, three. Okay.
All right, guys. I think we're gonna keep start so you can reset the timer. Or is the timer running? Reset now. Up there as well on that screen. Does that show you 20 minutes?
Yes.
15? Okay.
Yeah.
All right. Pick it up.
Okay.
And jump on to stay kind of within that frame so that we make sure that we get the video. Don't move too far one direction.
So like this? Good?
Good.
Okay. So I'm Jean-Paul Smets. I will introduce today something called Open Process, which is actually fairly new in relation to recent problems of resilience that we find on the internet and that have led to a word called the Splinternet. The Splinternet is a word used, for example, by Tariq Krim at DLD conference in 2023. It's about the fact that more and more the global internet with a single source of information for everybody is now split, with Chinese having their own internet, European blocking sites from Japan, Russian blocking sites from US, and so on. So I'm the CEO of a cloud company called Rapid.Space, which is based in France with data centers also in Sweden, Germany, Japan, China, Taiwan, and more. And we have been doing open source since 2001. We made, for example, an ERP called ERP5, which is an open source ERP, now used by big car industry, Stellantis, Toyota, Mitsubishi. It has been used to run the whole Central Bank of West Africa. Also, it has been used by the Oregon Department of Transportation. It's a huge ERP capable of handling the billing of millions of customers in French highways, for example. And we've been doing edge computing since 2008 with an open source software called SlapOS, which is now used by Rapid.Space, obviously, but also by Würfel company in Germany for vibration management. It has been deployed by Stellantis. Stellantis is the merger of Fiat, Chrysler, Citroën, Peugeot, and Opel in various factories, and it's been used by some sovereign big data clouds in France, such as TerraLab. And we've been using Open Compute since 2018. We first started with Leopard servers. Then now we rather use AMD-based Mitre Capri. We use Edge Core for our switches. So we are a fully open hardware infrastructure at Rapid.Space using Open AOS, for example, as the network operating server on the switches. So open source hardware, open source software. We host an experience center in France, in Lille, so we can show to our customers, for example, how OCP can be used even with 19-inch racks. This is something that many people ask us in the enterprise or when they use traditional telco data centers. And on the left, we show how OCP can be used to deliver 5G or 4G infrastructure. We have open compute servers, high-power radio head, and we show how to connect them to build a Taiwan telco 4G or 5G network. This is the kind of things you can experience. We ourselves did open source hardware because we thought if we benefit from open source hardware from OCP, we should also give something. So we've designed a radio board called the Open Radio Station that is entirely public. And if you put that little board in a box, you get the kind of 4G or 5G private network that industrials or defense love. For example, this kind of board can be used to power the radio of soldiers in a main battle tank or in a vehicle to transport military troops. Open source hardware. We provide edge cloud based on this. So you can see the full video online. I will skip it. And now we have new challenges. The first challenge is that we see that the modern internet doesn't provide any more privacy. There are laws in every country that prevent guaranteeing privacy of people's data. We'll see that soon. The second thing is now we have non-tariff barrier that prevent using in country A a cloud service provided by country B. And these kind of laws are growing and growing, which means we cannot consider the internet or the cloud as a single place anymore. And number three, we have now state-sponsored terrorism that cuts cables under sea to cut some parts of the internet from others, some part of the cloud from others. So this is the Splinternet, the fact that what used to be a single space is becoming divided in mutually no longer connected spaces. What can we do to survive in the Splinternet if we rely on cloud? That's what we are going to explain. So, privacy. This guy there, Mr. Pierucci, has been in jail for 3 years in the United States because his company was doing business, I think, from France to Pakistan, and they provided a commission to some people that was higher than what OECD laws on corruption state as the maximum level of corruption, I think 3.5%. And he was arrested when he went to New York, and all his data that was exchanged with his company on Outlook was actually used by the Department of Justice to keep him in jail for 3 years until his company was acquired by General Electric. So it was a kind of a power and economic game for GE to acquire Alstom. The story has been fully explained in various books, translated in, I think, more than 10 languages. What's behind that is a law in the United States called the Foreign Intelligence Surveillance Act. Under this law, combined with the Foreign Corruption Practice Act, if you do business even outside the US, you can be arrested by Interpol outside your country for having done that business infringing US laws that are applied outside US. That's called extraterritoriality. Due to that, many people are stopping to use cloud in large corporations. The same type of law exists in China. It's called the Chinese Cyber Security Law that gives similar powers to the Chinese government. And there's the same law in France. It works a bit differently, but we have the same. So, if you use cloud, there's a problem now. Governments have the power to monitor you and potentially arrest you outside your country when you are doing business. This creates a lot of distrust, and a solution is needed. Non-tariff barriers. The GDPR has rendered today the use of Google Analytics illegal in the European Union. If you use Google Analytics on your website, you can be sued anytime for violating the GDPR. This has been confirmed by most privacy authorities in the European Union. In China, it's called ICP Bayan. You have also ITAR regulation. Countries and nations, one after the others, are putting laws that prevent using the cloud service from another country. How do you survive that? Imagine you're a multinational company, you want to have the same services in all your factories in the world, but in every country they are telling you that the service provided by another country is illegal. It's very annoying. And that's the last point. That's an event that happened in Egypt. The cables in the Mediterranean Sea were cut on purpose. It was not an accident. Then the whole 4G or 5G went down in Egypt for nearly 1 day. This kind of incidents where submarine cables are cut tend to increase recently. So if you depend on a cloud that's connected to you through those cables, you are taking a risk to be disconnected for quite some time. The same risk exists, for example, in 4G or 5G core networks of mobile radio systems that are also single points of weakness of modern infrastructures. So how can we overcome those risks? And this is the solution we propose. In traditional cloud, the operation process of the cloud is secret. You cannot copy AWS service because how it is made is secret. There are 10 data centers with 10,000 servers, for example, in, let's say, in small clouds, with one providing having 1 million customers. These are very few data centers and a lot of customers under a single organization. If we can move this type of architecture to all operation process being public, which means anybody can copy them to create a copy of the whole cloud service. Instead of 10 data centers of 10,000 servers, 10,000 data centers of 10 servers. It's harder to destroy. And instead of one provider with 1 million clients, 100 providers with 10,000 clients. We change the topology of the service to have a distributed service with tons of smaller providers. Then the providers can be in different countries. It is harder to destroy one or destroy cables and cut access. It is easier to adapt to a wide variety of legislations. The three problems that were mentioned previously, which are privacy or non-tariff barrier or state-sponsored terrorism, are solved. So this is how we have built Rapid.Space. What we have done, we have described the hardware we use, and we give a list of all the vendors. We have described how the cloud service is provided, how we train our staff, how we do the routine task to maintain the service up. And all the process, we are documenting it online in a handbook. So it's a huge task. It's not yet fully finished. But we are already able to ask a third-party company to build a remote site just by reading the documentation. And the training of the staff becomes accelerated. We already have a clone supplier that does like Rapid.Space, but is not Rapid.Space, and follows the same procedure. So what we are essentially doing is applying to service the same ideas as open source previously applied to software or hardware. We try to make a service that can be copied, improved, extended. And we call that open process. So we have open source software, software that can be shared, improved, copied, open source hardware, hardware design that can be shared, improved, extended, and now we have open process service, a service such as a cloud service that can be shared, improved, extended. And therefore, we are creating the path towards having hundreds of suppliers following the same process as we do. But we came to a little blocker, the nature of the hardware that is needed to provide edge service. With OCP, we need currently to have a minimum of 16, for example, Capri servers to bootstrap a site. Sometimes it's a bit too much. We need something smaller. And sometimes we need to bootstrap sites in countries where import procedures are complicated. We tried OpenEdge. We thought it was a bit too big, a bit too expensive. And so we started to study how we could make the edge infrastructure smaller, cheaper, to have it distributed in more points of presence more easily. And we came to a list of needs that we believe are the needs for an edge platform that matches the kind of customers or deployment we do. So it should be low cost. Number two, fit in cabin luggage. If you go to Africa and take a server with you, no problem. You put it in your cabin luggage. In 24 hours, you bring it, set it up. If you do a regular export-import, there's often a procedure of 3 months of pre-approval before you can actually ship the hardware. So you lose 3 months. So being able to carry something in a cabin luggage is actually a very important point to bootstrap a point of presence. We've done it many times. And currently, OpenEdge doesn't fit in a cabin luggage. It's a bit too deep. Then it should be immune to extraterritorial law. So now we have servers with US CPUs from AMD, Chinese CPUs from Hygon, and European CPUs from NXP. Then this way, we let our customer choose who they want to be monitored by. And it should be suitable for enterprise, not only for telcos. The kind of server you put in a factory of Stellantis is not exactly as powerful or big as an OpenEdge, which was designed for telcos. When it comes to telcos, they want more and more DRAM, which means the server is at the bottom of the macro station. That means much less powerful than an OpenEdge. And we see our telco customers still demanding less powerful, smaller machines. And we should support CPRI, not eCPRI, because the world standard is CPRI and has not been changed at all to eCPRI, and the wide majority of deployments of radio systems is based on CPRI, not eCPRI, so we should support that. So we designed something quick and dirty. It feels like going back 20 years ago with screws. It's horrible to open and service. The edge part of Rapid.Space has a beautiful yellow, but it's far from as beautiful as an open compute design system. So we think we should improve the design of mechanical design of the edge pod by integrating into it all the OCP know-how to make systems that are screwless. I believe OCP should create a platform optimized for CPRI when it comes to edge, because CPRI is the standard and is cheaper to deploy than eCPRI. And next action, so I think the OCP Foundation should move to a neutral country like the Eclipse Foundation did. This is very important because if you look, for example, at the Apache Foundation, they have export restrictions. So for example, if you download a software from the Apache Foundation, put it in a German car, and sell the German car to Iran, then the export restrictions defined by the Apache Foundation apply to the German company that embedded a bit of open source software from Apache and shipped it to Iran. It's just an example. So this kind of export restriction that are put on top of open source licenses are creating a huge legal risk when it comes to international trade. And they become an incentive to try to find a foundation that does not enforce such export restrictions. And currently, if a foundation is headquartered in the US, it has to enforce those export restrictions. That's why moving to another country, if you want to work with the whole world, is mandatory. Else, there will be not a Splinternet, but Splinter Foundation for the same reasons. The other call for action is, I think, open process is a valid idea. That's not open source, not open hardware, but maybe could be included in a repository of the OCP Foundation so that we don't provide only hardware, but we also explain how to use that hardware to render a service. And that could be a nice extension to the idea of open compute. Thank you.
All right. We have time for a couple questions. Any questions for Jean-Paul? I just want to highlight a couple things from his talk. First of all, carry on OCP luggage. I like that a lot. And second of all, I've never met anyone as passionate about opening up every single thing that they do and every step. So the manuals that they do produce are quite amazing. And you've done virtual installs with headsets.
Yes.
In remote countries.
Yes, with smart glasses.
With smart glasses. It's really quite amazing what their team does. So I encourage you, if you're thinking about doing things locally, anything around their new device as well, and it doesn't necessarily just have to be telcos.
No.
It can be anyone that's looking for some sort of edge use case.
Yes.
Talk to this guy. Doesn't matter where you are, he will make it happen. Thank you very much, Jean-Paul.
Thank you, Steve.